Hey there. Ever wonder how AI models like ChatGPT or Gemini really learn to solve complex problems? It's not just about memorizing words, it's about understanding the building blocks of ideas. Today, we're diving into a game-changing technique called concept-aware fine-tuning, CAFT. That's rewriting the rules of how AI learns language. Let's break it down. So here's the problem. Traditional AI models are trained to guess the next word in a sentence. Think of it like learning to cook by only seeing the next ingredient in a recipe. It works for simple tasks, but when you're dealing with coding, math, or even chemistry, this next word approach falls apart. Why? Because these tasks require understanding relationships between ideas, not just stringing words together. That's where CAFT comes in. Imagine teaching a model to see the big picture instead of just the next word. Instead of predicting one token at a time, CAFT lets models predict multiple tokens at once. This helps them grasp concepts like benzene ring in chemistry or loop structure in coding, ideas that span multiple words. It's like giving the AI a map instead of a single step-by-step instruction. The secret: 2 clever tricks. 1. For training auxiliary heads on general instruction datasets to help the model recognize concepts. 2. Dynamically scaling losses to focus on the most important parts of the task. In experiments, CAFT blew away traditional methods. For example, when generating code, it handled tasks with multiple concepts far better. In chemistry, it accurately produced molecules with specific functional groups, like the benzene or amide parts you'd see in real drugs. But why does this matter? Well, traditional training is computationally expensive and hard to tweak. CAFT is cheaper, easier to implement, and works across domains, from coding to protein design. It's like giving AI a toolkit that's both powerful and accessible. So what's next? CAFT isn't just a tweak, it's a shift in how we think about training AI. By prioritizing conceptual understanding, we're paving the way for models that can tackle real-world problems with more common sense and creativity. And that's just the beginning. Thanks for watching. If you want to dig deeper into how CAFT works or see examples, check the links in the description. Stay curious, and we'll see you in the next video. But here's another breakthrough. Researchers are now training models with smart shortcuts in the process. Imagine a training dataset with 100,000 samples, pulled from chat logs, math problems, and coding challenges. Think of it as a supercharged toolbox, covering everything from multi-turn conversations to complex problem-solving. But here's the clever part. They didn't just throw all that data at the model. Instead, they created auxiliary heads, extra brain modules that focus on specific tasks. Picture one part of the model handling math and another writing code. These heads act like specialized tutors, guiding the main model to learn more efficiently. How do you make sure these tutors work together? That's where CAFT hyperparameters come in. The team introduced 3 keys, alpha, beta, and gamma, that control how much the model relies on these heads. Think of gamma as a fading spotlight. It starts strong to highlight important clues, but gradually dims as the model gets the hang of it. This prevents the model from getting distracted by too many hints later on. The results: the model became more robust, handling tasks like protein design and coding with fewer errors. And here's a kicker. By focusing on these targeted shortcuts, the team slashed training costs by over 60% compared to traditional methods. It's like upgrading from a gasoline engine to a hybrid. You still get power, but you burn way less fuel. But this isn't just about speed, it's about smarter AI. Think of breakthroughs like AlphaFold, which revolutionized biology by predicting protein structures. Now, researchers are taking it further, teaching models to reason in continuous spaces. Instead of rigid step-by-step logic, AI can now think more fluidly like humans do. This could unlock solutions for climate modeling, drug discovery, or even understanding the human brain. And let's not forget the tiny details that make a huge difference. Ever notice how some AI chatbots sound more human? That's thanks to tokenization, the way models break down text. A recent study showed that how we split sentences into tokens, like words or parts of words, affects everything from translation accuracy to math problem solving. For example, a model might struggle with unusual words if they're split incorrectly. By optimizing this process, researchers are making AI smarter and more reliable. So what's the big takeaway? CAFT and these smart training techniques aren't just incremental improvements, they're redefining what AI can achieve. By focusing on concepts, efficiency, and adaptability, we're building models that don't just mimic human intelligence but augment it. The future of AI isn't just about bigger models, it's about smarter ones. Stay curious and let's keep pushing the boundaries together.